Hello and welcome to URP 475, the section on water and globalization. So why do we care about water? Well, besides potable water, which is drinking water, water has a lot of other uses, and these include everything from using water for agriculture, water as a solvent for cleaning, water for recreational uses, and of course for drinking. And also, water is of concern with respect to natural disasters as well. So this lecture goes into what the water cycle is. Basically, you have precipitation, and then condensation, rain, and then evaporation. Um, and when we talk about water, we are also really concerned with the cost, both in terms of energy as well as in terms of actual cost, financial cost of water procurement. And this is because the vast majority of the Earth's water is 97% is in the oceans. The stuff that we can really use for drinking is fresh water, and that's 3%. And out of that 3%, two-thirds is in ice caps and glaciers, not accessible. And although global warming has caused some of these to melt, it is still, the vast majority is not accessible. About a third, 30% is groundwater, and the rest is in surface water. So what you actually see in lakes, for example, freshwater lakes, is just 0.3% of 3%, right? So think about that. That's much less. That's less than 0.1% of the total water supply on the planet. And out of this 0.3% that is surface water, now remember 0.3% of 3%, that is surface water. The vast majority, 90%, is in lakes. The United Nations gives us some estimates of what water availability is, and of course this varies from region to region. And what you'll see in some of the later charts is that water is very available, at least on a per capita basis, in regions that have heavy precipitation. So I think rainforests, South America. On the other hand, it's not very available in temperate and arid zones like sub-Saharan Africa. So in these parts, water availability on a per person or per capita basis drops precipitously, quite a bit. In densely populated parts of Asia, for example, the availability is somewhere between 1,200 cubic meters and 5,000 cubic meters. Based on this and the growing Earth's population, we estimate that you will have several billion people that will be in water scarcity by the 2025 mark. As I mentioned, there are several sources of fresh water. There's surface water and groundwater. Some of this groundwater comes from aquifers, which are water-bearing rock formations that yield water in economically usable quantities, aquifers. And you've probably heard of this word before, underground aquifers. And what we really care about, well, we care about all aquifers, but the unconfined aquifers are really important because they're recharged by rain. The confined ones are more difficult to recharge because there's no direct precipitation that can get into them. Sources of water, as I mentioned again, there are quite a few of them, but the vast majority of water is unusable on this planet. So as a resource, it's something that we really have to be very considerate about, because even though there is a lot of water on the planet, what we can really use for human uses is a very small fraction. If you want to look at these stats a bit more in detail, you can go to the Aquastat portion of the Food and Agricultural Organization here. That is a UN body, and really sort of drill down deep into the data if you're interested in that. Okay, let's take a look now at how water is used throughout the world. The vast majority in the world is used for irrigation. Irrigation, that means for producing food. And then some is domestic use. This is what you and I would use water for in our homes, and then the rest for industry. Now, this is worldwide use. In the US, actually, water is not used for irrigation. The biggest category of use is not irrigation. We'll see later what it is, but it has to do with electricity generation. If we look at water availability throughout the world, the darker the region, the more per capita water availability, the more red or orange the region, the less. And of course, as I was mentioning earlier, a lot of this water scarcity is in these tropical zones right here, right? Sub-Saharan Africa, India, South Asia, East Asia, Southeast Asia, and so This chart looks at the percentage of population that has access to an improved water source. And what this basically means is that the percentage of the population that actually can access potable water easily. In some cases, you can have potable water. Let's say you have pretty good underground or groundwater resources, but if you don't have enough infrastructure basically to tap into that, your population is still going to be without water. So sub-Saharan Africa has the greatest percentage of people that do not or don't have access to an improved water source. In the darker bluer regions, these are the regions where most people have, more than 95% have access to an improved water source. The rest of the charts, I'm not going to go into much detail here, but they look at basically water distribution in terms of annual precipitation and then percentage of fresh water and then per capita water. You can look at these as well on your own. This chart looks at the water extraction by sector. This should be sector. My apologies. And as you can see, in developing countries, a lot of the water is used for agriculture. As we get to developed regions, more and more of it's used for industrial and municipal. So it depends by the region. Here we have some more maps that look at rainfall or precipitation by region. Again, red means more arid, dry. This is again the Sahara region in Africa. So near the temperate zones here, in the middle, you have less precipitation. Rainfall in the rainforest regions that I mentioned earlier. Lots of rain right here. Lots of rain right here also in Polynesia. This is the total renewable water resources per inhabitant. This is sort of a map that looks at some of the data we had looked at earlier right here. And what you notice is, again, the darker the blue, the more per capita water availability. And this is measured in cubic meters per year. Let's move through some of these charts. I'll let you look at these on your own. Okay, let's look at now water use in the United States. And what you notice is some of this data is a bit old. Unfortunately, it has not been updated much since then. But this comes from the United States Geological Survey. And what you notice is that the biggest category, about 50% here, is used for thermoelectric production. That is electricity generation. And then about a third, 31%, is used for irrigation. So this is, again, the same pattern that we see in developed countries, that more and more water is actually used for industrial processes, electricity generation, as opposed to agriculture. As we go to developing countries, poorer regions, water is used more for actually agriculture. And then roughly a tenth, or about 11%, is for public use in the United States. Some data at, again, water use in the United States, how much was taken out on a daily basis. 410 billion gallons per day were extracted for all uses, and out of this, about 85% was fresh water. If you look at population growth here in this chart, it's shown in red, this red line, or pinkish red line. Population has grown, and if you look at the blue bars right here, this is total water use, right? So it's kind of flat right here, starting in 1985. Total water use is flat. All the population has grown. So what this is actually showing us is that per capita water use has actually fallen in the U.S. because population growth has grown. Population growth has occurred in the U.S. However, total use has remained flat. So as we have not necessarily used more and more water starting in the 1980s, despite having a growing population. You see this here again. This chart disaggregates water use by sector. Again, thermoelectric is the biggest sector right here, as you can see that, and then followed by irrigation. If we look at water use in the U.S. by states, what you notice, again, California, Texas, some of the states with the biggest population, of course, will use the most water. But on a per capita basis, this is a little bit harder to see. What you notice is that the states that actually have highest per capita use, and it's actually not shown in this chart. I don't know if I'd included this chart here, but in another chart, highest per capita use are actually in regions like Wyoming and North Dakota, South Dakota. Why? Because population density is really low. And in places like California, population density is higher. Per capita use is actually a little bit lower. New York, which has lots of people, but they're living in a very dense environment, at least in Manhattan, per capita use is actually very, very low. So just because a place has a lot of people does not mean the per person use is a lot. It's actually in regions where you have population that is low in density, population density, that is the number of people per area is low, that you have the highest per capita use. And this is one of the things that, in terms of, we'll look at this later, in terms of green building, that becomes really important. And is that and this is why new urbanists are always sort of clamoring for higher density development, because the per capita cost of resources, the per capita use of resources, both goes down the more dense development there is. So when you have sort of New York style development, uh, the actual number of resources on a per person basis is lower, whether it's electricity or water or whatever. And the reason for that is because distances are closer, right? You have less energy loss associated with moving resources between people. Water supply in the US. Again, not surprisingly, globalization has impelled urbanism, which has increased reliance on public sources of water. And you can look at, your own lives, or how you procure water, and it's highly unlikely. Some of you, this may be true for maybe a few of you, but most of us rely on a public source of water, a utility company. We don't really have wells in our backyard. Again, this is very consistent with the theme that we have been exploring so far. What is that theme? As globalization facilitates movements into cities, people are increasingly reliant on other entities or the market to provide them with both necessities and for discretionary goods or consumer goods. You are more obligated, you are more beholden, you are more reliant on things and people other than yourself. Looking at domestic water use in the US, that is the water use at home, the largest category is outdoors. This is to basically water our lawns. Now you're looking at this and you're thinking to yourself, well, this is something we can absolutely do without, and I would agree with you, right? 58% used for outdoor use. It's something that we actually really don't need, except, lawns are an aesthetic thing, front yard lawns. And so that's why when we had the drought recently here, was sort of the first thing to go. Every other category is much smaller than that, as you can see, for dishwashing, for bathing, for clothes, toilet, and so on, much smaller than outdoor use. On average, the average person in the United States uses something like 99 gallons per capita per day. And this can really vary from state to state. In some states it's 100 gallons or 99 gallons per capita per day. In other places it's as high as 200 gallons per capita per day. In some places it's a little bit lower. But on general, we're around 100 or so. And if we start employing water conservation measures, we can shave off probably 20 gallons per capita per day. So what are some water-related issues? Well, there's water scarcity, right? Water use, of course, varies by region, and a lot of it's a function of what we use water for. I mean, in the U.S., we're using so much of our domestic supply here for irrigation. I'm sorry, for outdoor watering our lawns. We don't really need that. In other places, they don't really have that. So the United Nations estimates that to serve your basic needs, you need something like 20 to 50 liters. How much is a liter? 1 liter is about 3.8 gallons. So divide that by maybe 4. And so you need somewhere between 5 to 15 gallons per day to really meet your basic needs. In contrast, in the US, we're using 100 gallons per capita per day, in some places much more than that. So water-related problems that are arising increasingly as people move to cities, as people use water for a variety of resources, and there are a lot of them. I mean, the biggest one is that many people don't have access to potable water, but many people don't also have access to water for irrigation. And then many people don't have access to water for their other needs as well. Now remember, water is not just used for drinking supply for human beings or to grow food for human beings, but it's also used to grow food for animals and also for drinking for animals. And as globalization has resulted in movement to cities, has resulted in increasing reliance on markets, has resulted in an increasing dependence on factory farming, and an increasing shift, as we learned in our food lecture, towards animal source foods, water needs have also gone up because animals consume a lot of water. And it's just not animals, we're eating more meat now, that is requiring more water, but the byproducts of this urbanization and industrialization and greater reliance on factory farming and animal products also results in more water pollution, and which is also a pretty significant problem. And also some of the things that the consumer items that we sort of purchase are heavily water reliant. And what are they? Well, they are things like sodas or alcohol, all of which have a substantial water input need. Uh, a bottle of Coke, for example, 1 liter of Coke requires, and this is the same for a beer, I think, requires about 3 liters of water. So for every Coke, can you're drinking that's 355 milliliters, you're requiring something like 1 liter of water for that one can, which is quite a bit. And then in the United States and other places where water is used for electricity generation, again, more consumer items, more electricity need. More electricity need also translates into greater water need. So all of these are intimately linked together, right? As people, again, move to cities, as globalization favors cities, as globalization causes a rise in incomes, our consumption of goods and services and products goes up, our consumption of food goes up, and all of these have not only greater energy needs, but they also have greater water needs. And this can also lead to a host of water related problems. And I mentioned some of them here. Again, increasing water need, of course, is the biggest one. But water pollution, waterborne diseases, water related disasters, siltation. This is increasing silt in water supplies, and then a management of rivers and dams. And sometimes this can be a pretty big problem. Why? Because rivers are of course naturally occurring, but sometimes because we need more power from these rivers, we'll build dams. Now, in the United States, we haven't really built a dam in a long time, but China, for example, as many people in China slowly move to cities, as incomes go up, again, it's the same story plays out. There's a greater need for electricity generation, and China is building a lot of dams. And this is true of India as well and other developing countries as well, because they are looking for different ways to get power. So what are some of these issues in developing countries? And again, I discussed some of these right here. But basically is that not enough water is available. And when sometimes water is available because of weak basic legal frameworks for regulating water use, there's a lot of stealing of water, sometimes by corporations. There's a video that I used to post in the past. I'm not sure if I have posted this, but you can look this up on YouTube. And it's basically the relationship between a big company like Coca-Cola and how they move into different areas throughout the world where you have weak water laws and really, extract a lot of water from the groundwater supplies. In some cases, like in India, leaving local farmers without enough water for their agricultural needs and their daily needs. Other issues in the developing countries, water deprivation sometimes both is a cause of poverty and is also caused by poverty. In other words, when people are deprived of water, they must turn to sources of water that are not necessarily very good for them. So they have a higher incidence of certain types of diseases. And because of this, they have a higher morbidity, mortality cost, which perpetuates poverty. And the reason that they have poor water access to begin with is because they're poor, they're living in slums, right? So these issues, again, are all sort of intimately connected. And the incidence of waterborne illnesses as well as the prevalence of waterborne illnesses is, of course, much higher among developing countries, among those living in slums. And many of these, if you are living in the United States, you have heard of or you have no personal experience with, because we really don't have these issues over here. This chart also looks at disease burden and water-related, or rather water and the relationship between water and disease burden. And what you can see here is that poor water management is, again, directly responsible for lots of mortality and lots of what we call disability-adjusted life years, meaning people who are sick for a long time or are sick longer than they need to be sick because of poor management of water issues, as well as poor healthcare access and poor nutrition in their regions that they are living in. Here I want to briefly discuss the regulatory frameworks for looking and using water. And why is this important? It's because, if water is not very well regulated, the regulatory frameworks for dealing with water use don't exist, what you end up what ends up happening is that some people, basically those with more money, more power, sometimes corporations, sometimes people, sometimes rich people in developing countries, end up using a lot more water than is really fair, right? And so in the United States, we have several, rules and regulations that have evolved over time, but these basically fall in one of sort of two broad areas. One is loosely referred to as land-based or riparian rights. The other one is prior appropriation. These riparian rights deal with basically allotting the use for water in a sort of equal way based on land rights, right? So I give you some examples here. And one important thing to remember here is that water cannot really be owned, right? If you think about it, water can't be owned because it is constantly going through phase shifts. Even when you drink water, at some point water does come out of your body. It goes into the sewage system, right? And it's recycled there. If water it comes to the ground through precipitation, it'll infiltrate through the ground and replenish the groundwater supply, or there'll be runoff, right? But water is constantly going through a cycle, so it can't really be owned, and so we have to regulate use, and that's what these rights and the regulatory frameworks are all about: is to regulate water use and to make sure that people have their fair usage. This can become very important, and here we look at prior appropriation, which developed in the West. But this can become very, very important because when you're dealing with transboundary water issues, for example, much of the water in California, or a lot of the water in California, is not necessarily local water, right? We get our water from Northern California, Central California, as well as from the Colorado River. Now, increasingly, if Californians are demanding more and more of this water, those who have equal rights or greater rights to their water, right? Maybe Colorado River, for example, is not necessarily a river that starts in California, right? So we may not have the same rights as those in Colorado, right? So these rights become very important. Who has rights? Who has more control? Who has what right to use how much? Who has right to pollute? Who pays for cleanup of this pollution, and so on? In developing countries, like let's take Nile for as an example, the Upper Nile and Lower Nile, right? Egypt because it's a more powerful country. It controls a lot of the downstream pollution as the Nile moves into southern parts of Africa, as it goes to the Sudan and so on. Egypt is more developed, so more pollution can go from Egypt to regions that are south of Egypt, right? But they have less power to regulate that than does Egypt. So these kinds of transboundary issues become very, very important. And in the context of globalization, as some countries develop faster, they have greater water use. They tend to use up more of the water supply of rivers and bodies that go across nations, leaving others with less water, or polluting that water and leaving the pollution basically, or clean up the pollution, to other nations. So it's very important to have these kinds of regulatory frameworks that regulate water use, not just between states or cities, but also between nations. And there's a video posted in one of your modules that looks at that, water as a source of conflict, right? And here we look at the water and conflict nexus and the sectoral distribution of 145 different agreements on transboundary water resources. What this basically means is that when you have transboundary or water use across different boundaries, what are the major issues, water-related issues that these agreements are about? And so hydropower, again, which is dams, which is sort of the biggest issue. But there are other issues as well, right? Who gets to fish and how much, and who cleans up pollution? What about flood control? And then what kind of water can we use for industries, and so on? All of these are part of basically managing water in a world where water use is going, through the roof, or increasing significantly, especially in countries as they're industrializing and population is growing. Okay, I hope that has given you a good overview of water use, water-related issues. Some of the other material posted in this section looks at some of these these issues a bit more in context and with more specificity. I hope the biggest thing that you get out of these three sections, food, water, and energy, is that they're A, basically interlinked, B, that these issues are exacerbated by globalization, by the tendencies that are created by globalization. And those tendencies, again, I'm sort of repeating this ad nauseum, but it's important that you understand that globalization leads to urbanization, leads to greater market reliance, which leads to greater economic output, which leads to greater demand on the natural resources of this planet. Globalization also leads to greater waste production and a polluting of the resources of this planet. So it's not my intention to say that globalization is good or bad. It's just that these are the impacts, and how we address these impacts is critically important because they impact all of us, whether you live in developed countries or developing countries. It's of importance to all of us, and these issues are not going away anytime soon. And these issues cannot be simply addressed by technology. A lot of these issues, and as you'll see, if you studied any of these resources in greater detail, have to be addressed through basically a fundamental shift in how we approach consumption and how we approach capitalism and globalization. Um, and the thing to remember is that most people in the planet, whether you're in a rich country or a poor country, they want the same things as every other person. They want the access to a good life. And how a good life is increasingly defined is by the consumption of goods and services that are produced in the market. Okay, in the next section, we will look at energy.